Precalc 7-4 extension systems of nonlinear equations. So we've solved systems of equations for years, but we always had lines. And this year we're going to be looking at, because we're already graphing conics, we're going to be looking at all these different conics and lines, but we'll be looking at where they cross, what's going on. So in the first one, it looks like I have a y and then an x squared. So this is going to be a parabola. My second one's just a line. So if I think about all the different ways a parabola and a line could cross, it's possible that I could have two solutions. It's possible that I could have one. So I just want to be thinking about maybe the picture of what this could look like as I'm going through and solving. So it looks like this one would be pretty easily set up for substitution. So that's what I'm going to show here. So our methods are still substitution and elimination. So I'm going to use substitution on this one. So I want to take that second equation. I'm going to solve it for y. So first I'm going to add the y on both sides. So I have y plus 9. And then I'm going to subtract the 9. And now I have something to substitute into the first equation. So I'm just going to go ahead and write that out. And then I want to distribute and kind of simplify and clean it up a little bit. So at this point, I can tell I definitely have a quadratic. So anytime I have a quadratic, I want to get everything on one side, 0 on the other, and hopefully factor. So we want everything on the same side as x squared. And then we'll factor it. And it looks like I will definitely have two x's, which means this line crosses my parabola in two places. So we get 4 and 2. So now I need to go through and find my y values. So I'm going to use that y equals 3x minus 9. When x equals 4, I want to go through and substitute and solve that. And make sure you write your answers as ordered pairs. So my answer is 3 for y, so that's going to be 4, 3. And then when x equals 2, I'm going to do the same work steps. So I get negative 3. So 2 comma negative 3. So if we did not do these ordered pairs, I would just have a bunch of x's and a bunch of y's, and it's hard to tell what goes with what. So we really want to write the ordered pairs. And be careful that you don't write like the 4 with the negative 3, because when I plugged in 4, my answer was 3. So we really have to watch for that as well. So the second one, I have my x squareds and my y squareds in columns. So I'm going to use elimination on this one. So it's not the only method, it's just the method that it seems like it's set up for. And I have, let's see, an ellipse and a circle. So they could cross in 4 places even on this one. So let's go ahead and do this. I'm going to make my second one negative, add them together. I never subtract, I always just add a negative. So x squared equals 1, square root, absolute value. So x is going to be a positive or negative 1. And then I need to find y. So I'm going to use the x squared plus y squared equals 10. And I'm going to start with x equals 1. So that means I'm going to have a 1 squared plus y squared equals 10. So we can kind of already see the answer here. We just have to go through and show the work. So I get a plus or minus 3. So I started with 1, but I got 2 answers for y. So now my answers need to reflect that. So I had 1 for x and 3 for y. And I also have, when I start with 1 for x, I get a negative 3. So now let's look at what happens when x equals a negative 1. Well, when I have a negative 1 squared plus y squared equals 10, that's going to simplify to 1 plus y squared equals 10 again. So I already know, following my work on the left, that my y is going to equal a positive or negative 3 again. So if I start with negative 1, my answer is 3. And if I start with negative 1, my answer is a negative 3. So I end up with 4 solutions. So if we think about like a circle and then an ellipse, it could cross it in 4 places, and that's what we've got going on here. So looking at the next one, it looks like it's set up for substitution. It looks like I could easily substitute this stuff in for y. This is not going to be our best move. I'm going to explain why in just a minute. I just want to also mention that my first one is a parabola and my second is a circle. So look at what happens when we substitute. I'm plugging in everything for y, x squared plus 3, and then I'm having to square that. So when I square that binomial, I'm going to get an x to the fourth and a 6x squared and a 9. So it's not that I can't solve that, but it's kind of ugly with x to the fourth power. So I want to just look at our other options. We could still go for substitution. And I just want to write here, there is an easier way. So the way I could do substitution is instead, I could substitute for my x squared. So if I subtract 3 on both sides, y minus 3 equals x squared. And I could take that second equation, x squared plus y squared equals 9, and I could substitute the y minus 3 in where the x is squared. So we can do those kind of tricky substitutions here. So y minus 3 plus y squared equals 9. I'm going to subtract 9 on both sides and reorder this. And then factor. So let's see, either y plus 4 equals 0 or y minus 3 equals 0. So we got our two answers here. And then let's see, what was my original? My original was y equals x squared plus 3. That looks easier to now use, maybe. I don't know. So negative 4 equals x squared plus 3. I already see an issue here. If I have negative 7 equals x squared, when I do my square roots, I'm going to have something imaginary. So this is going to be extraneous. So let's try 3. That means I'll have 0 equals x squared. Square root, absolute value, but it's just 0. Okay, so when, let's see, what did we use here? Y was 3, x is 0. So that's going to be 0, comma 3. And this makes sense. If I think about my original equation, that first one, that parabola, it would be at 3 on my y-axis. It has a y-intercept of 3 and then goes up. And my circle has a radius of 3. So it'd be 3 all the way around. And so they would cross right there at the vertex, just in one point. I could also even have used elimination on this. So let's just take a quick look at that. If I had done elimination, I know it looks weird, like maybe I can't get that to work, but that first one I would just rearrange and make negative x squared plus y equals 3. And then my second one is x squared plus y squared equals 9. And if I add them together, the x squareds would cancel. I'd have a y squared plus a y equals 12. So just because I don't have exactly those same variables does not mean that I can't do elimination. So that's possible as well. So our last one has kind of a trick to it, which I like, something a little bit different. That was our goal with these, to give you one of each kind of problem. So, and the issue is that that second equation has x and y multiplied together. I'm going to have to divide by something. So I'm just going to choose to divide by x, so that y equals 54 divided by x. And then I'm going to substitute that in the first one. And we're going to have to work right away to get rid of fractions because we don't want them. So I'm substituting. That's really the only way. Elimination is not going to help this one. Let's see, 3 times 54 is 162. So 162 divided by, this was an x. I don't know how that morphed into a 4, but we fixed it. And the issue is, of course, the x in the denominator. So I want to multiply everything by x to get rid of my denominator. And so when I multiply x times 2x, I get 2x squared. X times that middle one, now that x is gone in my denominator. But now I do have a 36x. So I want to rearrange this because I have a quadratic again. And then my next step is going to be to divide everything by 2 because I don't want to factor this without doing that. So then I have x squared minus 18x plus 81. All right, that looks familiar. That's a perfect square. So x minus 9 times x minus 9. So I'm really just solving x minus 9 equals 0. So I get x equal to 9. And then I know that I have that equation xy equals 54. So that means I have 9y equals 54. Divide by 9, and so y equals 6. So my ordered pair is just 9, 6. And I didn't really think about shapes in this, So let's go back and think about this. The first one is definitely a line, and the second one looks kind of unusual. We haven't looked at these in this chapter, but we have graphed them before. And this is actually a hyperbola. These were our first hyperbolas that we graphed that we have not done in a while. So it's a hyperbola that would look like this, where we have our y-axis and our x-axis through here. So it's that kind of hyperbola. So we've got something like that. And then for the line to cross in just one spot, it must be like something like this, where it's just crossing it at the corner there. So this is it for our 7-4 notes. If you have any questions, please ask them in class.